In this video, we'll talk about references, something that has actually been underlying everything we've done in Python, but up to now we may not have been aware of it. It's the idea that every value that we have in Python is stored in memory. And every variable is a name that points to that value. Something we call a reference or a pointer. And it's not something we've had to think about before. It's clear enough to us that if we assign some sort of a value, or let's say a container of values, to a name, that later on we'll be able to use that value, we can append to it, etc. And that's all well and good. But I have a question for you. Let's say we were to assign one variable to another, as we're doing here. Would we end up with two lists or just one list? In other words, is it fair to say that when we assign x to y, are we making a copy? Is it fair to say that? Or is it possible that y and x point to the same value, in this case the same list? Well, it shouldn't be too difficult to figure out just through a test. If we were to append to y, would we see, and then print x, would we see ABC or would we see ABCD? If there were two lists, if this made a copy, then appending to y obviously would not affect x. But if it turned out that there was only one list and both variable names were pointing to the same list, then we would see ABCD. We would see this instead of just ABC. So let's run it to find out. And there it is, sure enough. When we appended to y, it affected x. This means that there's actually only one list. Now, to understand that, we need to resolve something in our minds, because this isn't necessarily intuitive. And most people, when I ask this question, one list or two, their answer is two. When you assign x to y, you're making a copy, so x is different than y. But here we can see that no, x is definitely not different than y. X is the same list as y. So how can we conceptualize that? Well, we go back to this idea that a variable is a name that points to a value in memory. So we really want to think of the value and the name as being stored in different places. They're not the same thing at all, actually. The value, or in this case a container of values, is stored in memory at a particular location. And it's helpful to think of your memory board. We all know what RAM is. You know that when you buy a computer, more RAM is better, and that the RAM is the operating memory. And that's all true. It's helpful to think about our RAM at this point, because when we create a value, any value at all in Python or in any language, that value needs to be resident somewhere on our computer system. It needs to exist somewhere. And by being stored in memory, a value takes up space and it has a location such that, as I mentioned before, if you assign a value to a variable and then you refer to that variable later on, what Python does is it looks for the value that A points to or refers to. In other words, the value 5 in this case is not actually stored with A at all. It's stored in a separate location for memory, or on your memory board. You can think of it that way. And that memory has a location, and that the name A actually only knows the location of what it points at. It's not even necessarily aware that it's pointing to an integer. It just has an address, a specific place in memory where that value can be found. So when we print A, Python sees A, and then it looks up the value using the address. So when we say y equals x, we are assigning an address, the address that x points to y. So wrap your mind around that idea that when we do any kind of assignment, there's two parts to a variable. And there's two parts to this assignment. One is the name, and the other is the value. And those two things are stored in different places. And when we make an assignment like this, we're assigning to the name an address where, and it's a memory address, so we can say a memory address. Assign a memory address. Assign the memory address. I sometimes use this graphic. When we say A equals 5, we can think of 5 as just being on memory. And if I could draw like a memory, if I had any drawing skills at all, I'd make a memory board and I'd put 5 on the memory board and I'd give it a little address. And 5 has an address on the memory board. It's in your RAM. And when we say A equals 5, we're saying A points to 5. Not that A equals 5, but A points to 5. So A and 5 are actually not at all the same things. A is a name, 5 is a value. A points to the value 5. And when we say B equals A, what we're saying is let B also point to 5. In other words, A and B are unrelated. They actually have no relationship other than they both point to the same memory address. So when we say x equals ABC, and then we say y equals x, what if we were to just delete y at this point? Let's delete y. This is we can say deassign, or we'll say disassign. So it no longer points to the value. And if I try to print it, I'm going to get an error. When I run this, I see that I was able to print x because x is still there. I mean, it still points to the value, I should say. But since we removed the y from our variable set, it no longer points to that list. Del is sort of like the reverse or the inverse of assignment. It's disassigning. Y no longer has a value, and so we get a name error here. So this is going to be true throughout our exploration of variables, and in particular of higher order functions. Let's do another one here. Let's say I've got this list, and again, just remember that assign this list, assign the address in memory where this list exists, where this list can be found, to x. I'll say to name x. Now here I'm creating a new list of 3 integers and then x. I want you to remember that when we look up the value for x, we're asking Python to take the address in memory that is assigned to x and go find that value and then do something with the value. But when we do an assignment like this, what are we assigning in the 4th element of y? Is it a new list, ABC? Is it a copy of x, of the list that x points to? Well, let's find out. Let's, why don't we modify, here I'll print y, I'll modify x, and then I'll print y again. And if I do, I'll see that y initially has, and this is something we've gone into. This is a list that contains another list, but we see 1, 2, 3 ABC. Great. That makes sense because the fourth element of y is a list. But then if we modify x and then take a look at y, we see that y also sees the change. This also, again, underscores that everything is assigned by reference. Everything is assigned by reference. Now, this will be a preview of our next video, but the question would be this, or we're getting into it here. Let's say I was to pass x as an argument to append me. So we know that this means that arg equals x. It means that the variable arg is what? Equal to a copy of x, a new list ABC, or the same list? That's the main question. If we're saying that arg is the variable name that points to the x, well, I mean, I think I've answered my question. It points to what? Is it pointing to x? No, actually, it's pointing to the same list. So then again, the question would be, let's say I was to print x. What am I going to see? Am I going to see ABC or ABCD? Well, let's find out. Okay, ABCD. Now, why would this be? Again, you have to remember that every assignment that we make, anytime we say, let's let this equal that, let's say this name is equal to that thing, it's a reference, it's a pointer, it's an address. It's all those things. It's a reference, it's a pointer, and it's an address. And it's not the value at all. It's just an address that points to that thing. So if we pass x, what are we passing? We're actually passing a reference to ABC. And so when we have arg up here, arg is also pointing at ABC. Again, remember the drawing. Two names that point to the same memory space. That means that if we modify arg, that means that x will of necessity be modified. It's not that we're modifying two lists simultaneously. It's that we're modifying one list and that list is pointed to by two different names. Now, it is true that once we leave the function, arg no longer exists. And if we were to try to print arg, we would see a name error. But that doesn't change anything about what we're saying here. The fact that arg no longer exists is meaningless because when we said arg.append, we weren't appending to arg. We were appending to a list in memory that x points to as well. And that's why arg may be gone, the way we got rid of y before. But x continues to point to that list that was once pointed to by arg. Now, this can be a little bit challenging, and it's important that you have this concept pretty firmly in your mind. So if you've gotten to the end of this video and you're still not quite sure of it, we want to watch it again and see if you can get it firmly in your mind, especially when you consider this diagram. 5 is the value in memory, and A and B are simply names that point to that value. In fact, there's a table of variables, and that table of variables is basically one column is the names, and the other column is the address of where that name points to. So that's how we handle variables in Python. And this will be an important lead-in to our understanding of higher order functions.